Just to remind everybody, hopefully everybody knows the schedule for today. First off, thank you all for being here. We're very excited to detail what we're going to try and get off the ground here in QTEC, and look forward to you guys going on lab tours and finding out more about the program and hearing from entrepreneurs and residents and things like that. To get started though, my name is Chris, by the way. I'll introduce myself again in a second. We have the director all the way from Stanford, because he's busy on his own commercialization stuff, that wanted to send in a message.
Hi, my name's Mark Thompson, and I'm the director of the Quantum Technology Enterprise Centre. Now, unfortunately, I can't be with you today, as right now I'm in Silicon Valley visiting a technology incubator. And this is a technology incubator that specifically focuses on hardware technologies and has ambitions to commercialize quantum technologies. And we believe that it's really important for QTEC to engage in these sorts of initiatives, to engage with investors in areas like Silicon Valley, so that we can really deliver on the potential that quantum technologies have and really try and move to translating quantum technologies out of the research laboratory and into the real world. And so I'm really pleased that you could all come here today to visit the centre to learn more about what we're doing, and I hope you find it very stimulating and very enjoyable. Now, the vision and aims of QTEC for us are really about delivering the future leaders of tomorrow's quantum technology industry, and taking technically minded individuals in the areas of quantum technologies and quantum inspired technologies, and giving those individuals the skills, the techniques, the mentoring, the environment, and the training in which they can take quantum technology based ideas and then deliver real commercial products and services and create business propositions that will be invested by investors that may be from Silicon Valley, maybe from the UK, maybe funded themselves or bootstrapped. And so we believe it's a very exciting time for quantum technologies. The UK government has invested £250 million in the research base within this area. There is huge amounts of investment going on around the rest of the world. Europe is poised for a 1 billion flagship in quantum technologies. Big companies like Google, Microsoft, IBM have got huge research programs in the area of quantum technologies. So it's pretty much well accepted that quantum technologies are coming. No one is quite still yet sure exactly what form those quantum technologies will be in. But we believe the time is right now to start to seriously consider how to commercialize these quantum technologies. And that is really the goals and ambitions of QTEC. And so we've teamed up, the University of Bristol has teamed up with Cranfield University. Cranfield University have a very prominent business school that will deliver a lot of the business training around the QTEC program. At Bristol, we have the expertise of the Quantum Engineering Centre for Doctoral Training, which can bring a lot of the quantum engineering expertise. We have a very prominent centre for systems engineering, at the University of Bristol. And so QTEC is really based on 4 pillars, which are quantum engineering, systems engineering, design and thinking, business, entrepreneurship, enterprise, and finally networking, and establishing a very strong network across investors, across technically skilled individuals, across the quantum technology landscape within the UK and worldwide. And so those 4 pillars come together to establish what is the Quantum Technology Enterprise Centre. And we are predominantly focusing on early stage postdoctoral researchers, as we believe these individuals have the technical knowledge that's needed at this stage to really understand the potential of quantum technologies. And then we augment that technical knowledge that they have with the business training that we bring with the Quantum Enterprise Technology Centre. And so I hope that you have a very enjoyable day. I hope that you are able to understand what QTEC is about and what QTEC can bring for you. Please spend time asking questions for lots of my colleagues, and I hope to meet you when you start in October 2016. Okay, thank you very much.
So once again, a big welcome to all of you to coming here to see our launch of the Quantum Technology Enterprise Centre. My name is Chris Erven. I happen to be the Deputy Director of QTEC, and I'm going to give you just a brief overview of exactly what we're trying to get off the ground here. There's plenty of time that we've saved for questions and answers. So if you have a burning question, by all means ask it. Otherwise, there's going to be plenty of time after this presentation to answer all your questions. So a quick word on the management team. You've just met Mark, who's one of the 2 co-directors. We also have Shai Vayakarnam, who's director of the Bettany Center for Entrepreneurship at Cranfield University. And they're the second key cog in QTEC to really get a lot of enterprise and business training into QTEC. You've got me as a deputy director. We've got the center manager, who's Andy Collins. Andy, wave. He's at the back there. We've got a systems engineering lead that we just put in position, who's Neil Carhart, who's also at the back there, waving. We're currently interviewing for our enterprise lead, a number of strong candidates. We're sort of taking our time because this is a key position in QTEC. And a very strong steering committee. Professor David Mays at the back there, also the co-founder of XMOS, as well as being a professor of computer science here, and he's going to say a few words in a second. We've got Noah Linden, who's head of math and head of the Quantum Information Research Group here at University of Bristol. Patrick Godfrey is a professor in engineering at the Systems Center, and Professor Jeremy O'Brien is the director of the Center for Quantum Photonics. So a very strong team to lead this. And a number of important partners covering industry, a few other academic institutions, the hubs, which you'll hear more about in a second, and some other incubators that we're drawing from as well. So not everybody in the room might know the full sort of breadth of the quantum tech program. I figured I'd just give a quick recap. As Mark mentioned, about 2 or 3 years ago, the UK government decided they were going to put £270 million towards a quantum technology program. They really saw a key bit of expertise here, and they really wanted to accelerate that and the development of that technology. And they did it in a number of ways, but it's key to pick up on the fact that they didn't want to just develop science. They wanted to develop technology, and they wanted to push it out to industry so they could do things like become a global supply chain player. So they funded 4 quantum technology hubs that are here on the right. You've got the QTEC, which is the quantum imaging hub, focused on how can you use quantum techniques to image more precisely. You've got the Quantum Communications Hub, focused on what are the applications of some quantum communication devices. And I should mention that Bristol has a part in each of these 2 hubs. Then you've also got, in Oxford, the Network Quantum Information Technologies. They're networking small quantum computers together. In Birmingham, you've got the Sensors and Metrology Hub. And I should have said, QTEC is housed out of Glasgow, led in Glasgow, and the Quantum Communications in New York. You've also got 3 quantum centers for doctoral training, which Mark also mentioned. We've got one of them here in Bristol, and there's another one at Imperial and UCL. Some of them have more of a theory slant. We're very engineering focused here in Bristol. It's nice to highlight. There's 3 training and skills hubs, and QTEC is one of those 3 skills hubs. We really saw, to use a bit of the business lingo we've been picking up, a gap in the market. There was all this money dumped into the quantum program at the academic level and to bring in sort of medium and big business. And we saw a gap there for helping to help startups and spin-outs off the ground. Because there's not too many Microsofts and Googles of the world that have millions of dollars to put into R&D just for the sake of it. Sort of the way of the world with innovation these days is the big guys sit back, wait for 10 startups to try it, 2 fail horribly, 6 do all right, and then 2 succeed. And then the big guys get involved at that point, either partnering or buying them up. So we want to really help the spin-out startup culture. There was a capital call. I couldn't find all of them on the web, but we have one here called QPIC, which is meant to get a short loop foundry service off the ground. So when we do our integrated quantum photonics here, we send them out to commercial foundries, and from sort of design to having the devices back, it's 6 to 12 months. This is obviously a little bit too long if you're trying to innovate. So we bought some key pieces of equipment and are installing them in our clean room so that we can turn 12 months into ideally something like 12 days to really sort of test out some design ideas using all of the same procedures and fabrications technologies that they use in real foundries, so that once we've got a design working in-house, we can immediately ship it off to a commercial foundry for scale. There's 14 individual quantum fellows that they also funded, and I think we have 4 of them here at Bristol. So this is covering things that weren't sort of broadly covered in the hubs. And there's also been multiple Innovate UK calls that have really tried to bring academics and industry together. But again, we saw a bit of a market gap. This has been sort of medium and bigger industries trying to join them up, and hopefully QTEC now can provide that last piece of the puzzle for startups and really small enterprises getting started. And these were both feasibility studies all the way up to sort of £1 to £2 million collaborative R&D projects. How about quantum now at Bristol? Because we have quite a broad range of programs as well. It all started basically with the Center for Quantum Photonics and also the Quantum Information Theory group here. And now all of it's basically rolled under our QTEC Labs banner, so our Quantum Engineering Technology Labs. So we have the Center for Quantum Photonics really focused on trying to build an optical integrated quantum computer. From that, we've added the Quantum Engineering Center for Doctoral Training. We train cohorts of 10 students with a common taught first year, and then they go and do 3 years of a regular PhD in a group at Bristol or even beyond Bristol. We're involved in 2 of the hubs, as I mentioned, the Quantum Imaging Hub and the Quantum Communications Hub. And now we've got QPIC that we're getting off the ground with the short loop foundry service, and QTEC, the enterprise center that you're all here to see today. Have to acknowledge all sorts of funding from EPSRC. And the other one worthwhile putting up there is we have a very successful program on the verification of quantum devices, because it's actually hard to verify whether your device is actually quantum. And that's sponsored by the Army Research Office in the States. And it covers the gambit from computer science to engineering, electrical engineering, computer engineering, all the way up to quantum information theory, physics, photonics, and partnerships with a high-performance networking group that's here. So how about QTEC's vision and its goals? We want to facilitate the development of quantum and quantum-inspired technologies, businesses, and entrepreneurs of the future. Our aim is to help all of you come in as fellows and get these technologies out of the laboratory into the real world, providing real services and devices that everyday people can use. You are not here to do research. We can't stress that enough. The year that you would be here is to develop a business plan and to figure out what problem in the real world can you solve with a potential quantum technology. As Mark said, it's a partnership between the University of Bristol and Cranfield. And the other big thing that lots of people might ask is it is all equity free. We just want to give you the skills to go and be a success. Please don't forget us when you're a success, and if you happen to donate back into the program, by all means do. But we are asking nothing in return other than to come here and work hard and make these things a real success in the real world. There's 3 pathways now that we have. The first is sort of a PhD plus-like experience, which we're calling Quantum Enterprise Fellows. We've seen how well the cohort-based model works in the CDTs. Putting a group of 10 highly motivated, highly intelligent individuals together in the same room really has made the benefits and the work they do gone up exponentially. They get so much more done. They learn a lot more. There's dedicated incubator space here on the 2nd floor, which you guys are going to get a tour of. And the idea is you will get an intense, front-loaded 6 months worth of training in enterprise, systems engineering, and any quantum engineering you need to pick up. And then the back half is a lot of free time where you should be really working on a business plan, a business case, such that at the end of the program, you have a business case in your back pocket, a presentation and a slide deck ready to go, and can pitch at a moment's notice to the right investor that you happen to be riding the elevator with in London or wherever you might be. Pathway 2, we just renamed it last night, to be honest. It's an ever-evolving program, but it's the accelerator program. So it's a little bit more bespoke and flexible for those that are already embedded in potential research groups, whether they be a good example is somebody in one of the hubs, but I mean, it can be easily broader than that. Any research group in the UK or worldwide. Or somebody with relevant experience in research, industry, or new enterprise creation. So much more sort of small business entrepreneurs. So it'll be a bespoke program that you can dip in and out of to upskill what you need to really get something off the ground. And then the third is our corporate program. This is for more medium and large enterprises that are interested in quantum. They know it's coming, but they really don't know how it's going to affect their business. So again, it's a bespoke program that we can come and they can learn about quantum and figure out how it's going to affect their business. And just, we always like case studies. So just to give you an idea, a flavor. So here's Alice. She just finished a PhD. She's our Pathway 1. She did a PhD at MPL on ion traps. She developed an integrated laser system to address all these ions. She wasn't quite sure academia was for her. So she heard about QTEC, got involved, and she's teamed up with 2 other QTEC fellows because they realized that this integrated laser system can not only address ions, but it can address neutral atoms and has a range of applications actually in the medical industry. So she's teamed up with 2 other QTEC fellows, and they're busy putting their business plan together for that. And she's on Pathway 1. You've got Bob here on Pathway 2. He's a postdoc from the Quantum Imaging Hub. He's been working on a photon imaging system with correlated photon pairs, and they want to get this out into the marketplace. And again, he's not quite sure academics is for him, and he really wants to see that he's keen on the technology. He knows it can do something, and he wants to get it in the real world. So he's dipping in and out of the program, and he's able to go back to make use of all of the infrastructure, all of the resources that the hubs have to continue to develop their prototype models. Because the thing I should mention about QTEC is we have funding to train you in enterprise, but we have next to no funding. This is why I said there's no research here. We're not going to pay for equipment. We're not going to set up experiments here. So being able to get people from the hubs in to upskill and then go back and nucleate a team with his other partners in the QuanTech Hub is absolutely in the cards, what we want to try and promote. And then you've got Charlie. He's an industrial software programmer, very good at what he does, a little bit bored with industry now. In his spare time, he happens to love quantum. And he had a novel idea for how to optimize a compiler for an eventual optical quantum computer. So he's going to come in and dip in and out of this corporate pathway and try and get a compiler-based software company off the ground. To give you an idea of the training, so this is the courses offered at Cranfield, and two of these courses, the ones in red, the fellows, you guys, are actually going to travel to Cranfield and be embedded in their MBA program. The first one is Entrepreneur in Context. Basically, what am I about to get myself into? What's it going to be like to be an entrepreneur? What motivations do you need? Personal drive, that kind of thing. Then we're going to move into assessing emerging technologies, of which quantum is definitely one. Not too many people nobody can claim to know everything it's going to do yet. So learning about markets and customer needs, you actually have to solve a problem in the real world is going to be very important. TRL levels, what IP you have to think about. Third is project management, which is going to be absolutely key. This is no longer going to be you and maybe your lab partner getting your experiment to work in the lab, and please don't sneeze on it because then the software will crash. You need all the skills in project management to develop a real, robust technology that you can take out into the real world. Funding and venture capital, as I mentioned, we've got next to no resources in terms of funding prototypes and the technology, and even it's probably beyond the hubs. We need you to go out with your business case and look for the right investors and get the right amount of funding and resources you need to really drive a demonstrator, potentially in a hub, out to a real-world prototype that I can drop on the floor and it's still going to work. And last, building a business case. We want everybody to leave business case in their back pocket that they're ready to pitch at a moment's notice. Adding in the systems engineering and thinking training. First off, learning to lead, because everything is going to be driven by you guys. It's no longer somebody's going to tell you what to do. You're going to start telling people what to do. And you're going to do it in this complex landscape that has politics involved in terms of what technologies can be used for, and everything else under the sun that you need to know. That's going to lead into problem structuring and tools, because again, you're dealing with the real world now. Problems don't come nicely structured on an A4 sheet on your exam. You've got to figure out what the problems are, figure out what the key bits you have to solve are, and that's what this is going to deal with. And finally, again, this is not an individual system in the lab that just has to work sort of once for your nature paper. You're going to design a complex system that works under robust conditions, and it might have to fit into a network scenario, for instance, or it might have to fit into the politics or the legal requirements of the day. And so that's what that covers. And then finally, we can dip in and out of our Quantum Engineering CDT. These are some examples of courses if you feel like you need to get upskilled. We've got the theory of quantum information, an advanced course there. We have a seminar series where we invite world experts in to talk about the different platforms. We're very good at integrated optics, but we don't have so much experience, for instance, in superconducting circuits or ion traps. And so we invite these experts in, and as fellows, you guys will be able to go and see these talks and sort of figure out exactly what's going on in the landscape. And then we also have a course in device engineering that talks about all those key experiments, those key devices that have been demonstrated so far. And we're really moving towards this year a focus on design and fabrication and really sort of engineering for the real world and those techniques. We've partnered with a key supporter of the center is Satsquared, and specifically Bristol's arm of it, Engine Shed. And you can see sort of the range of all the other courses that we'll be able to make use of in terms of looking at IP, international negotiation skills. These are all sort of 1, 2, 3D programs that you just go down to Engine Shed and get trained up on. Director's responsibilities, which is apparently so important that it has to go up there twice. So we really have a nice, strong resource, because the other question is why Bristol, and this is one key reason. Satsquared is the #1 university business incubator in the world now. It was just announced a couple of months ago, and we get to tap into all of that resource. In terms of the support you get, first off, you get a salary. You're not working in your parents' basements, going through your savings at a rapid pace. We'll give you a salary, some travel, and the associated costs for all this training. You get a desk in our incubator space upstairs. And you can apply for up to $200K in starter funds. This is sort of at the 6-month point where maybe you're applying for funds to go and travel to a couple of your key customers and find out what their requirements are, for example. Mentoring and coaching from entrepreneurs and residents, 2 of which we have at the back and are going to say something in just a second. Networking events with industry. We're going to have an annual investor showcase. And there's all sorts of things in existence that we'll send you to in terms of pitching your ideas. And again, there's this UK quantum technology program that has annual showcases we'll take you to. The Knowledge Transfer Network has a number of events to try and link industry and academia that we'll take you to. Just to show you the calendar of KTN, it's already very busy just for July. And intellectual property, I'm sure everybody's going to have a question about this. First and foremost, we're not expecting you to develop any IP when you're here. It might happen, but you're here to work on the business case for existing technology. We're expecting you to come having already worked out any background IP with that host institution. If you happen to jointly develop foreground IP while you're here with potentially a researcher in CQP, for instance, it'll just be worked out according to standard university procedure. And if you do happen to work out your own IP with maybe even another QTEC fellow, because you're a university employee, the university owns it, but immediately grants you a non-exclusive license for £1. So, I mean, the best you could possibly hope for. And with that, I'm pretty much done. Applications are due Sunday, August 7th, so if you haven't started, do it quickly. And the other thing I'll say before passing off to entrepreneurs and residents, for things like the CDT, we had a very strong vision of what we wanted to put on. For QTEC, we appreciate that this is the real world, this is industry. We're going to sort of co-create it with all of you. It's going to look a lot different 4 years hence from now. So by all means, pepper us with questions. No question is too out there. But don't be surprised if a couple of times the answer comes back as, we don't know yet. Already, we changed a few things just discussing this presentation last night.